what I want to attempt to do is kind of tie together what you've seen and talk about soil health, talk about water management, and how that all pulls together and how diversity affects that. So we'll establish a few things, and when we do go out in the sun, we'll look at the rainfall simulator and we'll see how different management affects how water infiltrates the soil. But so particularly, we want to start out with a few principles. And there's 4 soil health principles, but I'm going to get more basic maybe if there is more basic than those 4 soil health principles. And the first principle that I want to make sure that you take away is that we cannot grow plants without the biology in the soil. So a sterile soil will not support plant growth. It will not germinate a seed. It will not support a transplanted plant. You cannot transplant a living plant into a dead soil and it live. It's going to die. So we know that plants are dependent on the biology. Now, the second principle that I want to make sure that you understand is that the vast majority, the high 90 percentile of the microbiology that's in the soil is aquatic. It has to swim where it goes. It has to live in a water film. When that water film is gone, then it goes dormant. Now, if we've established these 2 principles, that the plants depend on the biology and the biology depend on water, then what we need to manage for is water. We need to understand the water cycle, and we need to understand what gets water into our soil. And that process is called aggregation. So these things that, little tidbits that Lauren mentioned and that Amy mentioned about glomalin is a sticky substance from fungi. And did you mention to them about the buffet, Lauren?
At least some groups.
At least some groups. So the first group I was on, and Lauren mentioned the buffet. And so you can't really go without talking about the buffet. And there's 2 things to understand about the food buffet. When we look at the biology that depend on the plants for their food source, that's a buffet. When we have a monoculture, we have ribeye on the buffet. But the other thing that Lauren didn't mention is that with any monoculture, the buffet is only open 6 months out of the year at best. The buffet just didn't open. So now it's got ribeye on it, but you can't even get in. It's not functioning. Well, actually you might get in there, but there's no ribeye on it, right? There's nothing there because the plant's dormant. So it's important for us to understand how this diversity thing works and understand the relationship and how dependent we are on water for that relationship. Now we know it takes a certain amount of water to make plants, to grow plant material. But by and large, what plants do, they take this water and they combine it with carbon, and they use the sunlight as an energy source through photosynthesis, and they make glucose. And that's C6H12O6. So it's just 6 parts water and 6 parts carbon, and we've got glucose and simple sugar. And the plants utilize that to do what plants do, right? So plants make more plant. That's what they're designed to do. They make more leaf, they make a stem, they go reproductive. They do their thing by doing this. But they also leak that sugar into the soil. So root exudates. Part of that sugar goes into the soil to feed the biology because the plant has to have it, right? So I'm going to take care of it. The plant's going to take care of that biology and make sure that it is alive and well and doing its thing. Now that we've established that, let's see what the power of diversity does. So now what we want to create is we want to create a buffet that is open 365 days a year, 24 hours a day, with every food you can imagine on it, at your disposal. At your disposal, every food you can imagine. Now you are happy. And now our plants are happy because our biology is happy. Because we've expanded we've expanded the diversity of that biology so that it is more than capable of providing every want of the plant. So if there is a certain bacteria that is responsible for phosphorus, a certain fungi that's responsible for nitrogen, a certain single cell, amoeba, or whatever you want to call it, protozoan that is responsible for potassium, and I'm making this very simple, then what we have to do is make sure they are there. We have to make sure they are in the populace. And, very important, that Rex brought up, that I expanded on to the last group, is just like not every microbe in the soil is good at everything, neither is every plant good at everything. So plants excel. There are plants that excel at promoting phosphorus uptake. And they will trade phosphorus to the plant next to them for potassium. But if the plant next to them isn't there, they have nobody to trade with. And so that's the power of diversity, both above and below ground. So, and we're going to get to this water thing here in just a minute. So now that we understand the relationship and the power of diversity and how plants can trade what they are good at getting, some plants are very good at moisture harvest. Okay? So warm season grass plants are very good at harvesting moisture from the air at night, because that's when they open up their cells and they collect moisture at night. Cool season plants are designed to get rid of moisture. Okay? They open up during the day and air out. They're really good at that. So, understanding the relationship between cool season plants pulling out some moisture whenever we're sopping wet, and we need to get rid of some, and warm season plants that are pulling in moisture from the atmosphere that are feeding everybody moisture during the drier times, is a very simple relationship right there. And those relationships get very complicated and very micronutrient based, and so we don't have to dig into all of that. Now we get to this moisture thing. We get to this water. Keeping our soil hydrated so that we have an aquatic environment comes down to the biological process. They eat sugar. They eat roots that are sugary. They have a diet high in sugar. So I called the last group, I said, everything that comes out of this biological life that's below the soil is sticky. Their poo is glue. And so when we look at that, we take the individual particles of sand, silt, and clay, and we combine them together in an aggregate. And aggregation is extremely important. So you don't have to always understand everything. It's just that you need to understand what makes it happen. Plant growth makes aggregation. Okay, so those plants and having that plant doing its thing up above creates this biological life, and this biological life creates aggregation. So when we take those sand, silt, and clays and we glue them together, we have this. We have this right here. So it's a very easily seen piece of soil. And when we put them together, they won't hold water. Water will run through there no matter how I put these aggregates, water will run through. There is no hope for me to keep my hands like this and dip out any water to drink. But if I don't have it glued together, then I have this. I have that trailer fender. I have an impervious, because what's happened is my soil will slake. And that is when these individual particles form a sealed surface and they slake together and water won't go through. So we get 42, 44 inches of rain a year, southwest Missouri, and unfortunately, most of it runs off. Most of it just gone. And we're going to see that demonstration here in just a minute. That does not keep an aquatic environment in our soil. So our biology wants to go dormant. And so when we see this happen, we dry out because our water has ran off. Our biology goes dormant. When it goes dormant, the grass goes dormant. Whatever's out there, if we can't get it the biological needs that it needs, it is going to go dormant and quit growing. Now, with that said, I would say, are there any questions in these two known principles about the dependency of plants on the biology and the biology on plants? That's good. And we know we've got to get the water into the soil. This aggregation process is of utmost importance for us to be able to support this type of grazing. And I think that you have seen on this tour the support of a very diverse forage, supporting a very diverse biology that is very much infiltration encouraging. The water's going to infiltrate here. So this stream out here, Rex had mentioned a cedar tree revetment out here trying to control the bank erosion because this creek over here, flash floods, it gets wild and it goes down. And that's what our watersheds do because we have not encouraged infiltration with our management. Now, the watershed that you crossed to getting over here, Rex said they do have control of that whole watershed. And the things that they have done, he can see in the stream dynamics of that water. He sees that there's water there. There's enough pools that stay that they have minnows in them. The stream runs a much more than it used to, whereas it did rain, run, go dry. And so that's what happens to our water. We know that the water is going to move through the watershed, but we are in control of how. It can go over the surface or it can go into the soil and move away slowly. So now I want to go to the next phase of this. And now that we've learned how to capture the water, I always tell people that if I want a rabbit and I want to keep the rabbit, the first thing I got to do is figure out how to catch the rabbit, right? I got to catch him. But then I got to learn how to keep him. And that's the water. So now that we know how to catch the water, how do I keep the water? How do I store the water? And it's organic matter. Organic matter stores water. It's the water tank. So 1% of organic matter will hold 1 inch of water in 6 inches of soil. If we look at just the upper 2 feet of our soils, and I increase the organic matter in that 2 feet by 1%, I can store 4 inches of water that I didn't store before. 4 inches of water stored is incredible. But when I start to embrace diversity and I start to cycle roots, because roots is where the majority of our organic matter comes from, because those plants are cycling those roots all of the time. They shed roots and grow new, and they shed roots and grow new, and that becomes organic matter. It would not be impossible for me to increase my organic matter by 3% in that 2 feet, giving me a water holding capacity of 12 inches more than I currently have. Now, if you're already at 3%, getting to 6 is tough. But if you're at 1.5, getting to 4.5 is not that hard, okay? So, and that's where a lot of our soils are. They're in that 1.5 to 1.8. There's a few 2s, but there's just a lot of our soils that are below 2% organic matter, and they should be at 5. But we've utilized that organic matter. We've burned it up. Overgrazing, tillage in our cropland, we have used that organic matter up. And so now we got to replace it. And that's how I replace that organic matter, is I encourage maximum root growth and maximum root cycling. Now I can catch the water, and now I can keep the water and utilize it. And I always have water in the soil profile for my plants to use, and I'm not 2 weeks away from a drought. If I overgraze, I am. Let's pull forward to the rainfall simulator and talk about that just a little bit. Now what we have here is what we call the rainfall simulator, and it's the most visual example that I can provide to show you how management affects water infiltration. So as we look over here, we have a hay field, and this hay field is hayed every year. It was just cut a couple of days ago. Yesterday I cut this tray. Day before yesterday I cut this tray. I scraped the hay that had been mowed off and cut the tray and put it in the pan. Went to this field here and cut this, and this field here is continuously grazed. It's set overstocked, has too many cattle on it all the time. This field here is pretty unique because it represents something that we promote and we talk about, and that is what I would call a fairly diverse introduced cool season pasture. It's got fescue, it's got brome, there's orchard grass in it, there's a little bit of switchgrass floating around in there, but it also had a long-term deferment. So it has not been grazed this year. It will be this fall, but it has not been grazed yet. And then we have an establishing, I'll call this an establishing diverse planting. And I don't know when we can use the word diverse, Rex. I don't know when we can throw that out there. But this is Big Blue and Indian, Little Blue, Switch, Gamma, and 2 different ryes. I call that diverse, but it's not as diverse as what we would see here. You know, when we start expanding that diversity and including 16, 20 different grasses, I think then we're really talking diversity. But now that's better than a monoculture of any kind. But I think there's room for improvement. But now you're the last group, and the element of surprise is kind of gone because you can already see what's going to happen, and you can see what happens whenever we put an inch of rain on there. That was 1 inch, and we'll just make it rain again. So we get these rains that come like this, and they pour on us, and we get a lot of water in a short period of time. And I want you to notice the front jars are runoff, and the jars behind are infiltration. And I want you to see that these 2 fields on the left are already running off. The rain hasn't started too long. Keep in mind, this will be the 4th rain we've got. And we do start to see some runoff on this field on the right. And again, I will expand that it is not a very, I would say it's still establishing. It's got a couple years to go. But there's a 1/2 inch of rain right there. So that makes about, let's see, 3.5 inches of rain. Right there is 3.5 inches of rain for today on these fields. And you can see that in 3.5 inches of rain today, this field, even though it's maybe four dominant species, the management is still encouraging the infiltration. Management is key. That soil surface never sees the sun. So we don't get the soil surface exposed to the sun. The biology are constantly working at the surface, creating that aggregation, and the water is able to get into the field. Now we have some pretty good infiltration here. After 3.5 inches of rain, we've had a little bit of runoff, and we're going to have some runoff. The studies show that, you know, if we have good management, that we only lose 2/10 of an inch of rain to runoff, and the other 8/10 works through the soil. If we don't have that management, we lose 8/10 and we only get to utilize 2/10. Very important to understand that when we expose the soil surface to the sunshine, we lose our aggregation at the surface. And when that happens, the water goes away right off the top. Questions? Yes.
Why is the hay pasture has more runoff than the unmanaged pasture?
I don't know if it's got much more, but it's got just as much runoff as the unmanaged pasture. And that is because what we do to that field is we take Rex here and we shave him on the 4th of July and we stake him out looking straight up. Now his face is not going to like that at all. So it's been a while since his face has seen the sun. And a hayfield, that biology is going gangbusters at the surface, and then one day we take a hay cutter in there and we shave it. And typically it's just like today when we do that, because we don't shave hayfields on a rainy day. We shave them on a hot sunny day, and the biology runs off. And so the biology goes away because it's hot, it goes dormant, it becomes non-aquatic very quickly at the surface, and we deaggregate because the glue from that biology only lasts about 27 days and it starts to break down. And so when we do this to these hayfields, we don't have any residue on the field. So even a hayfield oftentimes won't have very good aggregation on it even before the hay's cut, because it didn't have any residue, and until the hay got taller, the surface was exposed. And then we took it all off and we re-exposed it. So we have surface deaggregation that's really common on continuous hayfields. They just never get to the point where they repair at the surface. And we create the runoff. So what can we do? Hay earlier, hay taller, cut higher, taller haying, and rotate. Don't cut the same field the same field year in and year out. Never have a hay field. Lauren mentioned never having a calving field. Don't have any field that is a designated field for anything. Make sure you manage for randomness and intentional chaos. so that your fields, your biology, your grasses never know what you're going to do to them next. That's when they'll be the strongest. It's when your biology will be the most diverse. It's when your grasses will become more diverse, and they'll become stronger because the biology is stronger when they never know what you're going to do next. You know, he grazed this. He grazed this in January last year. Well, if you graze them in January every year, they know when you're going to graze them. You're going to graze them in January. But when they have that board meeting and say, you know, he grazed this in January last year, but it was July the year before, and it was March the year before that, what's he going to do now? Nobody knows. Can't figure it out. So they prepare for the worst. We could be grazed any minute. It might be a year before we're grazed. It could be tomorrow. And that's when we get the strongest. That's when diversity maximizes. I'll leave you with that thought unless there's more questions. It's hot.